Electrical Machine 2, paper code PCE 501. This topic is included in 5th semester syllabus of Knockout curriculum. Myself, Rumam Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra Sur Institute of Technology and Sports Complex. Formerly it was known as Dr. Sudhir Chandra Sur Degree Engineering College under GIS Group. In electrical machine, two chapters related to different electrical machines has been covered, and in this video content you will see that in Knockout what is the syllabus content and what is the lesson plan, what is course outcome and what is course objective, and students can what things can they learn from this course, that we will see through this lecture of Electrical Machine 2. So first I will start with Electrical Machines 2 of Knockout curriculum and its course structure. The paper code of Electrical Machine 2 is PCE 501. It is covered in semester 5th and within the duration of 6 months. Maximum marks of this paper is 100, and the teaching scheme here is theory of 3 lectures per week and credit point 3. For evaluation purpose of Knockout, we have decided to evaluate this course by using mid-semester examination and end-semester examination along with some internal assessments. In mid-semester examination, it carries 15 marks. Assignment and quiz carries 10 marks. Attendance 5 marks. End-semester examination 70 marks. That means internal exam or internal assessment carries 30 marks and end semester or external evaluation carries 70 marks. Total 100 marks of evaluation is needed for getting passed with this electrical machine paper of electrical engineering. This is very important chapter or very important part of electrical engineering students. It is a basic core subject of electrical engineering. So first I will tell the syllabus of Electrical Machine 2. It will cover fundamental of AC machine windings. Second, pulsating and repulsing magnetic fields. Fourth, induction machine. Fourth, single-phase induction motors. Fifth, synchronous machines. Sixth, special electromechanical devices. In these 6 modules, we will cover mainly the AC machines of electrical machines topic, and the DC machine and transformer part has been already covered in 4 semester syllabus of Electrical Machine 1. And continuation with Electrical Machine 1, this is the Electrical Machine 2 part, where mainly the 3-phase machines have been covered. So I have shown you a lesson plan of a particular 2 modules here, and remaining modules will be covered in the similar way. Here I have taken the module 2, pulsating and revolving magnetic field, which is the basic of single phase AC machines, and how this 3-phase supply and single-phase supply can create the magnetic field, the rotational field, what is the basic, what are the fundamental laws, that has been covered in these modules. And here I have shown you the lesson plan, and this is the day. In each day I will cover the portion that I have highlighted here. This is for module 4, single phase induction motor, and it will take lecture number 6 to cover the total module of single phase induction motor. In that way, we will cover the remaining parts also, like single phase induction motor, synchronous generator, synchronous motor, and special machines also. Now the course objective. The course objective is here to understand the arrangement of windings of AC machines, to understand the principle of production of pulsating and revolving magnetic field, to understand the principle of operation and characteristics of three-phase induction motor, to understand the principle and operation and characteristics of single-phase induction machines, to understand the principle and operation and characteristics of synchronous machines, and also special electromagnetic devices. And we have to solve different problems related to induction machine, synchronous machine, and special electromechanical devices also. Prerequisite knowledge. It is very important for any subject to have to need some prerequisite knowledge before continuing this new topic or new subject. So for prerequisite knowledge of electrical machine 2 is first one, basic electrical engineering, second one, electric circuit theory, third, electromagnetic field theory, and fourth, electric machine 1. These 4 subjects need to cover before going to electrical machine 2. Course outcome. What are the things students will able to understand? Explain various electrical machines. Classify different electrical machines and its applications, and industrial application and control of various motors. Those things students will able to understand and justify the course objectives. Welcome to my video lecture for electrical machine, code PCE 501. Today's topic, orientation of synchronous motor generator. Vice President Banerjee, Assistant Professor of Electrical Engineering, Dr. Siddhamishra Institute of Technology and Sports Complex. In previous lectures, I have discussed about synchronous generator and also compared with the difference between generator and synchronous motor. So today we will form the power equation of synchronous motor and generator, and we'll see what are the different sort of equations and how can we form their diagram of the difference of generator and motor to the relations we will see that. Basically, synchronous motor is a machine converts AC electrical power to mechanical power at a constant speed, that is called synchronous speed. So, synchronous motor is also a double excited machine like synchronous generator, and its rotors are excited by DC current and stator winding are connected to AC supply. The air gap flux is the resultant of the flux to both rotor and stator. An important feature of synchronous motor is that it can draw either lagging or leading reactive current from the AC supply. The line is very important that synchronous motor can draw either lagging or leading reactive current from the AC supply. And before starting with the equation, definitely I will highlight the principle of a synchronous motor. Basically, if we consider a 2-pole synchronous motor and AC supply given to the stator winding, a rotor magnetic field goes in the air gap, and the stator rotates at synchronous. Definitely we have given synchronous. So three-phase supply here are rotating magnetic flow. The air gap produces a field which rotates at synchronous. Angular current of the motor produces state-to-state magnetic field. Therefore, there are two magnetic fields in the machine. The rotor will change the align with the stator field just as two bar magnets will change align. Place here. Since stator magnetic field is rotating, the rotor and the rotating field of the stator. In order to develop a continuous torque, the two fields must be stationary with respect to each. This is possible when the rotor also rotates at synchronous speed. And the basic principle of synchronous motor operation is that rotor chases the stator magnetic. And in other words, the stator rotating magnetic field tends to drag the wire along with the pole of the stator and lock in with the sound to the rotor. Let's assume if the rotor is stationary, when a pair of rotating stator poles shifts across the stationary poles at synchronous speed, the stator poles will tend to rotate the rotor in one direction and then in the other direction. However, because of the rotor inertia, the stator slides by so much that the rotor cannot move. Consequently, the rotor does not move and we say the starting torque is zero. In other words, synchronous motor is not static. And this does assume that the rotor is also rotating at synchronous speed. It runs either at some speed or not at all. While the running in the main constant speed, it is independent of load. And secondly, it is not inherently self-starting. It has to be done to the synchronous speed by some means before it can be synchronized to the supply. And it can be operated under a wide range of power factors, both lagging and leading. And it will definitely running the counter torque is beyond the maximum torque, and that is the machine can develop. Now, we will come to our that is the power equivalent formation. This is the equivalent form of synchronous motor. Here, in all respects, the synchronous generator, except that the power didn't flow, is reversed. The equivalent circuit of generator and motor is same. Only the difference is the arrow of power flow. So here, EF is the excitation voltage, IF is the field current, V is the terminal voltage, IA is the armature current of phase drawn by the motor from line, RA is the effective resistance, XS is the series reactance per phase, phi is phase angle between V and I. This is the torque angle. And it is the impedance or phase of the armature. Now let the motor drop lagging power factor. So the equation will be using KVL formula. So the equation EF equals to minus equals to V minus IA with ZS. In case of ZS, we will put IRA minus JIA XS. Here EF is the EMF generated inside the motor. Now we have to calculate the complete power drawn by the motor. And in case of generator, EF is always greater and leading, but in leading than VF. And in case of motor, EF is always lagging than VF. So we consider that it equals to EF angle minus delta. So we have the phasor diagram for synchronous motor at lagging power factor, and a phasor diagram can be drawn. That thing I am telling you now. Synchronous motor is taking a lagging current from the supply. The supply voltage V is taken as reference phasor, For lagging power factor cos phi, the direction of armature current again lags behind the by angle phi or theta along the axis of Ia. The voltage drop curve in the armature resistance is IaRa. And phasor minus IaRa is represented here. It is in the direction opposite to the of Ia. The voltage drop phase in the simple reactance is Ia-XS, and the phasor of minus j Ia-XS is presented here. It is in a direction perpendicular to the phasor of minus IaRa. The phasor EF is equal to the phasor sum of V, and minus IaRa and minus j Ia-XS, these are all equals to F. That is F equals to V minus IaRa and minus j Ia-XS. This combines to B F. And here it is here. This is coming from B along with IaRa, along with Ia-XS, and it equals to F. This part we have done here. It can play an important role in the power transfer and stability of the synchronous motor operation. Now, let's consider that A is also power delivered by source, and we can represent it by V into Ia conjugate, where Ia is definitely V angle 0 degree minus EF angle minus delta. We can write it from the Field equation which we have previously, the whole divided by ZS angle beta. So, dividing both sides with ZS angle beta, we are getting VZS angle minus beta minus EF by ZS, this will be ZS angle minus delta plus beta, we have taken common minus beta. Now, directly Ia conjugate will be just conjugate of this Ia equation is V angle ZS angle beta minus EF by ZS angle delta plus beta. So this will be V into Ia conjugate, so it will be square by ZS angle minus V into EF by ZS angle delta plus B. These are A's. It's looking like A, but it is A's. Now, the real power drawn by the motor is V square ZS cos beta and minus V E by ZS cos delta plus beta, where this equals equivalent to J XS. XS equals to XS angle 90 degree. So, in place of that, we have put a cos beta, and XS is very greater than RA. So if RA is negative, then we can write directly that P equals to V square by XS cos 90 degree and minus V EF by X cos delta plus 90 degree. So from here we can calculate that F into P by XS into I delta equals to P. If RA is neglected compared to XS, ZS becomes X angle 90 degree. That thing we have taken. Now, generator mode power creation. Here the difference is the flowing of power. So the equation EF into P plus IA, yes. And EF is the field equation and this is the result. So lag power is when the machine overexcited. So that is P angle 0 degree. EF equals to EF and delta. So the total power delivered by the machine into AC equals to V into 3 into IA. We have taken this 3-phase power. So this is the phasor diagram we have already drawn in previous lectures. And so I will be EF angle theta minus V divided by Z is angle theta. So definitely the conjugate will just IF conjugate, that is EF angle minus delta minus P angle 0 divided by angle minus beta. So ultimately EF by this angle theta minus delta minus V by this angle theta. The equation of IF conjugate. Now if XS is very greater than RA, and we can also write that XS equals to XS angle 90 degrees. So putting this value, getting that P equals to EF into V by X sin delta. And here the real will be 3 minus P by beta by Z is cos beta plus V into EF by Z is cos beta minus delta. Same calculation which we done for motors, we have done for generator, and that is the equation we are getting. P equal to 3V to EF by XS sin delta. So since synchronous machine runs with constant speed, so this will be also our expression for torque. Whatever expression for power we are getting, that expression is also for similar for torque also. Because the motor is runs with constant speed. So up to that is for today's class. We have compared the synchronous motor power equations here in generator mode and as well as for motoring mode. In both cases, we have seen that the expression for power is similar for generator and motor, and here the difference is the current flowing in case of motor and generator. We have seen that of the equivalent equations, and we have calculated the power with help of the phasor diagrams of synchronous motor and generator, and we have taken the lag power factor case. We can also take the leading power factor or mean power factor case and calculate power for synchronous machine. So this total lecture I have taken note of the electrical machines by association, Laplace theory of electrical machines, and you can also go to the book of J.D. Gupta of electrical machines. Those books are very important for electrical machines purpose, and definitely there will be several numerical problems related to this power expression, and this power expression is also important for semester exam also, because the power expression related problems are generally coming, and the true power expression also comes results. So thank you all for seeing my lecture. In my next video we will again continue about some numericals on voltage regulations. So here we are finishing lecture today. In my next lecture we will continue about synchronous motor part, and that will be very important. So thank you all for hearing my lecture, and we are finishing my lecture today. I hope.